Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In today's video I will solve the fifth question, which is the last question of exercise number 5.5 relevant with chapter number 5 integration related with FSC part 2 mathematics. So inshallah with this question chapter number 5 integration of FSC part 2 mathematics will be completed, and inshallah in the next video I will solve different type of MCQs related with Academy series FSC part 2 mathematics chapter number 5 integration. So let's move toward exercise 5.5 chapter number 5 integration FSC part 2 mathematics. Question number 5 tells that use definite integral to find out the area between the curve f of x and the x-axis over the indicated interval AB. So the first part is f of x is equal to 4 minus x square while the interval is 0 to 3. So first we are going to find the x-intercept of the given curve f of x is equal to 4 minus x square. So for the x-intercept, this y, this f of x will be 0. So it becomes 0 is equal to 4 minus x square. Shift of 4 on this side, it become x square is equal to 4, so my x value will be 2 minus 2. So the given interval is from 0 to 3. So in this interval this 2 lies and minus 2 does not lie. Minus 2 does not lie, just this 2 lies. So my required interval will be from 0 to 2 in this interval 0 to 3. I will have 0 to 2 and from 2 to 3. So 0 to 2 and the given function 4 minus x square dx plus from 2 to 3, 2 to 3, 2 to 3 and 4 minus x square dx. Now in this interval 0 to 2, let's suppose I put 1 over here, it gives us positive value 3. So I will does not change this function over here. This is the second step to solve these type of questions. Now the second step is this, over here in this interval 2 to 3, I let's suppose put 2.5 over here, pi by 2. So it will gives me negative value. So I will reverse this function. It become x square minus 4 into dx. Now after this, apply the integral on this function. So it become 4x minus x cube by 3, and apply integral on this function. It become x power 3 by 3, and s integration is minus 4x. And apply the interval from 0 to 2, and over here the limit is from 2 to 3. Now by putting 2 over here, it become 4 into 2 minus 2 power 3 by 3, and by putting 0 it will give us 0. After this, put 3 over here, become 3 power 3 by 3 minus 4 into 3, then put negative sign and put 2 over here, become 2 power 3 by 3 minus 4 into 2. Now by simplification, it will give us area is equal to 11 by 3 plus 4, and by taking LCM it will give us the required area. A is equal to 23 by 3 square unit. So the given interval, by putting the last interval is 3, by putting 3 over here it will give us f of x y is equal to negative pi. So 3 and minus pi, and by putting 0 over here become y is equal to 4. So this 0 4. So this is actually the required area that we already found out, which is 23 by 3 square unit for the part number A. Now let's understand the second part of the same question number 5. f of x is equal to x square minus pi x plus 6. This curve and this function is given while the interval is from 0 to 3. So first of all, simplifying and factorizing this function. So x square minus 5x can be written as minus 2x minus 3x plus 6 comes down as it is. Now from over here take x common, so x minus 2, and from over here take minus 3 common, we left with x minus 2. So it become x minus 3 and x minus 2. So for x intercept y will be 0, f of x will be 0. So by putting f of x 0, we left with 0 is equal to x minus 2 into x minus 3. It gives us 2 value, x is equal to 2 and 3. Now my interval is from 0 to 3. So in this interval, this 2 is lies. So it means that the interval will be from 0 to 2 and from 2 to 3. So from 0 to 2 and from 2 to 3. Remember in this interval, the given function gives us positive, so it does not change this function. Now in this interval, 2 to 3, if you put any values, so this function will give us negative value. So when this is negative, gives negative value, we will multiplying this function by negative. So it become minus x square, it become plus 5x, and it become minus 6. So now after this, integrate this function, it gives us this, and integrating this function, it gives us this, and applying the limit from 0 to 2 and from over here 2 to 3. So putting 2, it become 8 by 3. Putting 2, it become minus 10. Putting 2, it become 12. By putting 0, it will give us 0. Now by putting 3 over here, it become minus 27 by 3. By putting 3, it gives us 45 by 2. By putting 3, it gives us minus 18. Then insert negative sign. Then 2 put over here, it become minus 8 by 3. Then put 2 over here, it become 10. Then plug in 2 over here in place of x, it become minus 12. Now it become 8 by 3 minus 10 plus 12 2. It become minus 27 by 3 45 by 2 minus 18. Minus into minus plus 8 by 3 10 minus 12 minus 2. So minus 2 multiply minus plus 2. So 2 minus 18 plus 2 minus 14. 8 by 3 minus 27 by 3 plus 8 by 3 gives us minus 11 by 3, 45 by 2 comes down as it is. Now by taking LCM, it gives us 29 by 6 square unit area. So the required area is 29 by 6 square unit. Now the graphical representation will be, by putting 0 over here, it gives us value of y6. So over here this is 0 and x, because on the y-axis the x coordinate is 0. Now by putting 3 over here, it will give us the value of y0. So it means on x coordinate y is 0, so 3 0. So my required area will be from this 2 to 3 and from 0 to 2. It means this curve will pass from this 2 and then it will pass from 3. So this is the required area. This shaded portion is actually the required area. Now move to the next part, or part number C of the same question, number 5. F of x is equal to x square minus 6x plus 8 while the interval is from 0 to 4. From 0 to 4. Now after this, f of x is equal to, by factorizing x square minus 6x plus 8, it gives us x square minus 2x minus 4x minus 6x can be written as minus 2x minus 4x. 8 will come down as it is. From x square minus 2x, take x common, we left with x minus 2, and from these two value take out minus 4 common, we left with x minus 2. So by grouping the term, it become x minus 4 into x minus 2 is equal to f of x. For x intercept y and f of x will be 0. So by putting f of x 0, we will get x minus 2, x minus 4, we will get two values, x is equal to 2 and 4. So my interval is from 0 to 4. So in this interval 0 to 4, out of these two values, 2 will lies. 2 will lies. So it means my interval will be 0 to 2 and 2 to 4. So 0 to 2 and 2 to 4. So in this interval 0 to 2, by putting, let's suppose 1 over here, it gives us positive value. So this function will come down as it is. Now in this interval, if I put 3 over here, it gives negative 1. So it means it will give us negative value. So multiplying this function by negative, it becomes minus x square plus 6x and minus 8 into dx. Now by integrating this, it gives us this, and by integrating this function, it gives us this. And applying the limit from 0 to 2 over here, and over here apply the limit from 2 to 4. By putting 2, it becomes 8 by 3 and it becomes minus 12. By putting 2, it becomes 16. By putting 0, it will give us 0. Now put 4 over here, become minus 64 by 3, and put 4 over here becomes 48, put 4 minus 32, then insert negative sign and put 2 in place of x in this function. So minus, put 2, so it become 8 by 3. By putting 2, it become 12. By putting 2, it become minus 16. So 8 by 3, it gives us 4, minus 64 by 3, 48 minus 32, 16, minus into minus plus 8 by 3, 12 minus 16, minus 4, minus into minus plus 4. So 4, 16, 4, it gives us 24, 8 by 3 minus 64 by 3 plus 8 by 3 gives us minus 48 by 3, and by taking LCM, it will give us 24 by 3. By further simplification, 24 by 3 gives us 8 square unit area. So over here, by putting 0 over here, it will give us 8. So by putting 0, 1, 2, 3, 4, 5, 6, 7, 8. So by putting 0, it will give us y 8. And by putting 4 over here, it becomes 16. By putting 4, it becomes minus 24 and plus 8. So 16 plus 8, it gives us 24 minus 24, it gives us 0. So by putting 4, we get the value of y 0. Now my interval is from 0 to 2 and from 2 to 4. So it will be passing from 4 to 2 and then from 2 to this point. So this is actually the required area for the part number C. Now let's understand the last part of the given lecture. In the last part of question number 5, a function f of x is equal to pi of x minus x square is given while the interval is from 1 to 3. From 1 to 3. So for x intercept y will be equal to 0, f of x is equal to 0, so pi of x minus x square. Take out x common, so we left with pi, and over here we left with negative x. Now by zero factor property, we will get two values of x because this is quadratic equation. X is equal to 0, and from over here by equalizing pi minus x equal to 0, it will give us the value of x is equal to pi. So we get two values, x is equal to 0 and x is equal to pi. Now 0 and pi does not lies in the given interval 1 and 3. Just one value lies 2. 0 and pi does not lie. So it means the only interval in this problem number, part number D, will be 1 to 3. So this is very easy. From 1 to 3, the given function is pi of x minus x square. Now let's suppose in this interval 1 to 3, I take a value randomly just like x is equal to 2. So by putting 2, it becomes 10. Minus 2 square gives us 4, so it gives us positive value 6. So does not convert this function into negative. So pi x minus x square, by integrating it become pi x square by 2. Integration of x square is x power 3 by 3. Now applying the limit from 1 to 3. So by putting 3 over, it become pi into 3 square by 2 and putting 3 it become minus 3 power 3 by 3. Then insert negative sign and put lower limit. Pipe into 1 square by 2 gives us pi by 2. By putting 1 over here it become minus 1 by 3. So pipe into 3 square by 2 gives us 40 pi by 2. It become 3 power 3 27 by 3 gives us minus 9. Minus pi by 2 and minus into minus plus 1 by 3. By taking LCM and by doing simplification, it will give us 34 by 3 square unit area. Now the interval is from 1 to 3. So by putting 1 over here, it will give us the value of y4, and by putting the interval x3 over here, it will give us the value of y6. So the required graph for this function will be passed from 3 and then it will pass from 1 and move to the point 1 and 4. So the required area is this, 1 to 3, and the required area of the given function is 34 by 3 square unit.